Hello, this is Adam Hansen, and this is my run chart and control chart presentation for PRM 613. Run charts are pretty much a line graph that's plotted over time. We see the example here on the right-hand side. There's no control limits, it's just data displayed in the chronological order. Moving to the other one, the control chart shows how a process changes over time, and it has control limits and an average or a mean. The green line across the center here is the average or mean, and then you'll see on the top red line is the upper control limit, and the bottom is the lower control limit. Each of them has a data point outside of the control limits, which could be used in a data collection type, or if you're trying to find a tolerance, could be used in any form that way. Expert opinions. With run charts, Anhole, he felt the charts are an outstanding way to see data, and they're a great way for viewing trends or shifts. We'll get into the example here in just a little bit where they're discussing, where I discuss kind of sales, and we plot that by the month. Run chart is great for that. Think of like a stock market. The shares increase or decrease in value over time, and you can look at that trend up or down. Control charts, two different articles. I'm not even going to attempt to say their names just because I have no idea how to pronounce them. Both agree that the control charts are best used over a long period of time. Short-term data samples simply do not show enough data variance. You could maybe take a control chart and may want to plot something for 5-6 months and not really get any variance in there, whereas if you ran it for 1 year, 2 years, let's say, as an example, you could certainly have a larger variance across that time frame. So control charts work better long term. The project scenario we're going to get into here, my example, is I'm going to, both for the run chart and the control chart, but for the run chart here, it's an air compressor factory that builds a set number of units per day across 2 different shifts. The market need seems to trend up and down at different times of the year with no obvious rhyme or reason. In my scenario, let's say that there's no summer rush or winter rush. There's no busier time of the year that really is easy to predict. So we're going to utilize a run chart and graph the sales numbers over the past 2 years and the sales numbers moving forward into the future, broken down by each month. So on our horizontal axis, we will have the month, and then on our vertical axis, we will have the number of sales. We'll be able to trend it that way. For the control chart, same air compressor factory, builds units for light commercial and residential use. Those tanks need to hold air at 150 psi plus or minus 5 psi for a pressure test. So we're going to build the tank, test it before we send it out to market, and it needs to shut itself off at 150 psi or pounds per square inch, and so that plus or minus 5 psi, so it needs to shut off at 145 to 155, so that 5-point swing on the 150 middle. There's been an increased number of units that fail testing, and we're going to use a control chart to plot the units on the pass and fail to determine what some of these issues are. The people involved for the run chart, we're going to use the sales analyst. He or she should be able to provide the sales history numbers, how many units have been sold over what different months and what years and all that. Historical data can be pulled to do that. Sales manager should be the one who compiles and displays this data, puts it into the format that's easy to read, easy to interpret, easy to understand. And then the production manager needs to view these results so they could staff accordingly. Is it a busy time of year? I need more people. Slower time of the year, less people. We'll get all that down into what the outputs are. We'll get into this. The control chart, quality manager would be needed. They can provide pass or fail numbers and help compile the data. Production manager would need to be there to view results and understand what's happening on the production floor, as well as the operator, a person from the production floor who's conducting the test itself. They're the ones who would see maybe it's the motor compressor itself, maybe the tank has a leaky weld, maybe the compressor doesn't compress it fast enough or hard enough. Whatever the case may be, there may be several different reasons for the compressor to fail a pressure test that might not be documented, but a worker on the floor would have that insight and information. The purpose for these tools and our expected accomplishments here for the run chart, this is going to be an easy display of which months have a higher sale. Is it summertime? Is it wintertime? And it'll be able to predict busier or slower times of the year. Mainly what we're looking for here, use some historical data, find out what we've done in the past. We could do future sales or future orders, depending if we're selling direct to the public or if it goes to a retail big box store like Sears, Lowe's, Home Depot, Menards. Control chart, we can identify a seemingly growing trend in failing units. Remember, at this point, we just feel that it is an increased number of units failing. We're not 100% sure just yet. We just kind of have the understanding that they are. And we're going to determine if they fail from not enough pressure or too much pressure. Either way would be a safety or a quality issue. Too much pressure is going to be quality. It's going to wear out the motor, it's going to wear out the bearings, the tank isn't made to hold it, so it becomes safety. Not enough pressure, the unit would have to run more often to compress more air to keep it where it needs to be. So the inputs for the run chart, in order for this tool to be effective, the information should be easy to obtain and should already exist. We shouldn't have to go data mining too deep to find this kind of stuff. It should be available. A simple report may be able to be run. Sales reports could be run, breaking them down by months. Reports can provide this information or maybe database screening. We could look for some help from our information systems. I'm sure it's difficult to read this chart here, but we would have the date of the sale on the left-hand column. The next column over is the number of units sold, and then we're going to get into the cost to sell, the sale price, the cost price, the taxes on it, the margins for contribution, all that good stuff, profits. But mainly what we're looking for is number of units and what month. Inputs for our control chart. The pass and fail stickers there on the bottom right are actually from a ladder safety inspection, but it's the same concept here. In order for this tool to be effective, the information should be easy to obtain and already exists, just like our run chart. What we really need here is the number of units that passed and the number of units that failed. It would be nice to know when they failed, did they fail from overpressure, did they fail from under pressure, actual test numbers of high and low pressure units. And reports can provide this information. We should be able to have this in a quality metric somewhere in our quality department should have that. So outputs, the run chart, it's going to show a trend in sale on a monthly basis. This could be used by a production manager to understand the busy or the slow times, and so we could schedule maybe different products on an assembly line, or we could schedule different work and projects for the staff to complete. Maybe there's been a change or a difference we want to make, or just freshen up the plant, repaint the lines. All of this, of course, depends if it's union or an open shop as to what we can and can't do, but not what we're discussing in this class. Human resources could also use this to help staff accordingly. Are we going to need overtime? Are we going to have projected overtime numbers? Maybe if we see that every year from May to July is the busy time, we hire some summer help. Pay a decent wage, bring in some summer help to get us through those big pushes so we don't have to run overtime. So on our chart here at the bottom as our visual example, we have the months going across the horizontal axis there, and the number is also underneath. January has had 72 sales, February 227, and so on. You can see that down the year there we get a bunch at the end, and the sales numbers are up the vertical axis there on the side. Run chart just has the data points and a line that connects them all, showing us how the data is flowing. Very simple and easy to understand. Outputs for the control chart. It's the same example off the front page that I had there before. This will show units that pass or fail the testing, fail from overpressure or under pressure. So our average, our green line in the middle, is going to be our 150 psi. The top, the upper control limit, or the top line, would be our 155. Remember, we had a 5-pound plus or minus, so 155 would be our upper control limit. 145 would be our lower control limit, because we're going to say that 150 is what it holds at. So this information here, we have all our data points down the center, and you can see in this example, we would have one unit that was over pressure, one unit that was under pressure. As this graph continued down the line with 700 compressors produced in a week, you would probably see a lot more outliers if there was a growing trend in units failing, and we would see more failing from over, more failing from under, or equally both, and then we know we've got several problems to fix. So this could be used by the quality manager to understand the amount of rework or defective units that are being produced. This could impact other aspects of the business or this project, being to produce compressors. In a number of manners, we would have to produce more units to create the required number of passable units, taking up more resources, time, and materials. Let's say, just for simple numbers, we had to produce 100 compressors in a day, but we had a 5% failure rate, so 5 of those compressors are going to fail. But if I need to produce 100 a day, I'm going to actually have to produce 105 because I know I'm going to make 5 bad ones. So that's going to take more people, more material, more everything. Bring it all in, and you're going to have to produce more just to produce enough passable. And you're going to rework. You're certainly not going to throw those ones that didn't pass in the garbage. We're going to try to fix them. So then we have rework involved, and the time and the effort and the resources that are consumed and all that. From a history of 7 years in custom manufacturing, rework will absolutely slaughter a profit margin and be very time consuming. Run charts here, the best use and the advantages and disadvantages for both the run charts and the control charts. Run charts are not best when needing an in-depth analysis. We saw on ours, it's a simple data plot, and we just did number of units sold in a month and then plotted that on a graph. It won't tell you profit, it won't tell you tax rate, it certainly won't say number of passed or failed units or any of that. It just says, here's the number, here's the month. Very simple. Control charts, they're not good for short time frames. The example I had only had 15 or 20 plots on it. If we're producing 100 in a day and we're only testing 20 of our units, that I would recommend to every unit runs through a test, if that's how the process is designed, but not what we're arguing in this class. So we will definitely say that you'd want to have a much bigger sampling group. This would go on over a long time to identify any type of shift or pattern being produced in an upper or a lower control limit. Additional quality metrics I feel that are similar to a control chart is a Pareto chart. Paretos, which I'm sure we will see in an additional presentation. I've used them in manufacturing to group common errors together. I didn't have part B. I didn't have the product on the time to meet the time schedule. Motor bracket didn't fit, whatever the case may be. Worked for Train Company building water chillers, and we used Pareto charts to track deficiencies. Whatever had the most deficiencies is what we went after to fix. Went after the big fish first. So how I use those there. And here is the references I used. I won't bore you to death and read you through it. So this is my presentation, and I hope you enjoyed.